The topic for today is all about relation and function. So, what is relations? A relation is a set of ordered pairs. When you group two or more points is a set, it is referred to a relation. When you want to show that that a set of points is relation, you list the point of braces. So, for example, if I want to show the point negative 3, 1, 0, 2, and 3, 3, 3, and 6, 4 are a relation, it will be written like this. So, so domain and range. So, its order for has two parts, an x value and a y value. The value of a given relations are called the domain. So the values of the relations are called the range. When you list the domain and range of relation, you place it's the domain and the range in a separate sets of braces. So for example, less the domain and the range of the relation. So negative 3, 1, and 2, 0, 2, and 3, 3, and 6, 4. So domain, negative, the set of domain is negative 3, 0, 3, 6. So the range is 1, 2, 3, 4. So number 2, less is the domain and the range of the relation. So negative 3 and 3 and 2, 0, 2, and 3, 3, and 6, 4, and 7, 7. So the domain is negative 3 and 3, 6, 7, and the range is 3, 2, 4, 2, 2, 4, 7. So notice even though the number 3 is less than twice in the relation, you only note a number once you list the domain or range. So what is function? So a function is a relations that assign of y value and one x value. So what that means? So it means in order in order for the relation to be a considered a function, there cannot be any perpetuated value in the domain. So there are two ways to see if a relation is a function. So number one, vertical line test. Number two, mapping. So use the vertical line test to check if the relations is a functions only if the relation is really graphed. So that you can see the that you can see that there is a graph. So hold number one, hold a string hint edge pen roller etc vertical to your graph. So number two, drag the strength edge from left to right on the graph. So number three, if the strength edge intersect the graph once in each spot, then it is a function. So if the number four, so if the struggles intersects the graph more than twice in any spot, it is not a functions. So this is a functions. So example of vertical line test. So you can see the number one is that is a functions and number two not a function, that because there is as not a function. So you can see a number three, this is not a function, and number two that is a functions. So this is a mapping. See, in the relation is not graph, it is easier to use what is called is mappings. So when you are creating a mapping of a relation, you draw two ovals. So in in one oval in one oval list all the domain value, in the others oval list all the range values, in the other oval it's the range value. So draw a line connecting in the pair of domains and range value If any domain value maps to two different range value, the relations in is not a function, so it is easier than it sounds. So example of a mapping. So create a mapping of the following relations and state whether or not it is a function. So that you can see the negative 3 and 1, so that is big connection. So connections at negative 3 and 1, so 0 and 2, so 3 3, so 6 and 4. There are there are 5 I 4 steps how to draw the oval. So number 1, draw oval. Number 2, less domain. So number 3, less range. So number 5, draw lanes to connection. So this is relation is a function because its x values map to only one value. So another mapping. Create a mapping of a following relations and state whether or not it is a function. So negative 1, negative 1 and 2 and 1 2 and 5 3 and 6 8. So negative 1, we connect negative 1 and 2, so 1 2, so 5 and 3, so 6 and 8. So this relation is a function because it's x values map to only one value. So it is still a function if two x values to go the same y value. So notice the that even though there are two two ends in the range, you only list the two ones. So last mapping. So create a mapping for the following relations and state whether or not it is a function. So negative 4 and negative 1 and negative 4 0 and 5 1 and 3 9. So negative 4 is connect the negative 1, so 4 and 0, negative 4 and 0, so 5 and 1, so 3 and 9. So this relation is not a function because the negative 4 maps to the negative 1 and the 0. So it is not a function if one x values to go the different y values. So notice, make sure the less the negative 4 only once. So vocabulary review. So relation is a set order first to domain. The value in the relations. So range. So the value in the relations. So functions are relations where each x value is assigned maps to one y value. So vertical line test using a vertical straight edge to see if the relation is a function. So mapping a diagram used to see if the relation is a function. So here so you need to practice. So this is a practice. So complete the following questions and check your answer on your text slide. So identity, we domain the range of the following relations. So letter A. So here are examples. So example and answer. So negative 4 and negative 1 and negative 2 to 3 and 1 and 4 and 2, and B 0 negative 1 and negative 6 and 1 and 2, 7 and negative 4 and 1 4. So number 2, graph the following relation in use the vertical lane. This to see if the relation a functions the connection the first in the order given. So A negative 3 negative 3 and 0 6 and 3 negative 3. So 0 6 and B 0 6 and 3 3 and 0 0. So number 3, use a mapping to see to see if the following relation to functions. So here A, negative 4, negative 1, negative 2, 2, and 3 and 1, 4 and 2. So number 2 is 0, negative 6, and 1 and 2, 7 and negative 4, 1 and 4, negative 4. So here are answers. So that you can see, the number one is domain. Number one, so identify the domain, the range of the following relations. So number one, letter A. So domain is negative 4, negative 2, 3, 4. So the range is negative 2 and 2 and 1. So number number 1 and na letter B. So that is letter B, the negative 6, 0, negative 6, 1 and 2, 7, negative 4, and 1 and 4. So that you can see is domain, the domain is 0, 0, 1, and 2. The range is negative 6 and 2, negative 4 and 4. So here are answers of number 2. So the question is the graph of the following relations and use the vertical test to see if the relations is a function. Connect the first of in the order of given. So that is a given. So you can see that there is a function. So letter A, so and B not a function because it's a it is the mm, uh not function. So number 3, so function A, if it is a function, so because negative 4 will be connect on negative 1, so negative 2 will be connect on number 2. So negative 3 positive 3 and it will be connect on 1. So 4 will be connect on 2. So that is a functions. So number 3B, so this is not a functions because uh, 0 will be connect on negative 6. So 1 will be connect negative 2. So this, so 1 negative will be connect number 4. So number 7, 7 will be connect 4. So that is not a functions that. So one more thing, the equations that represent a function is called a function rule. So a function's rule is written with a two variable x and y. So it is can also be written in a function notations fx, but we talk about that on when you can when you are give the function rule, you can evaluate the function to given domain value to find the response to range the value. So how to evaluate the function rule? So the evaluate of the function rule is substitute the value in for x and solve for y. So examples, evaluate the given functions rule for x equals 2. So this is our solution. So y equals plus 5. So y equals so the x is 2, so plus 5. So 2 2 2 plus 5 equals y equals 7. So y equals 2, x negative 1. So y equals 2, then 2, the x equals negative 1. So y equals 4, my negative 1 equals 3. So y equals negative x plus 2, y equals negative 2 plus 2 equals negative 2 plus 2 equals 0. So evaluate for a given domain. So you can you can also be asked to find the range value for a given domain. So this is a same for before now. Before, but now you can evaluate the same functions rule for more than one number. So the value that you are substituting in are x values, so they are a part of a domain. So the value you are generating are y values, so they are a part of the range. So example, find the range value of the functions for the given domain. So here are steps. So uh, sub each domain value in the one at a time. So solve for y and h. So number three, so let's a value in range. So that here are given. So y equals negative 3 x plus 2 and negative 1 and 0, 0 1 2. So here are solutions. So y equals negative 3 times plus 2 equals y equals negative 3 times negative 1 plus 2, y equals 3 plus 2 y equals 5. So y equals negative 3 plus 2, y equals negative 3 times 0 plus 2, y equals 0 plus 2 equals 0. So 3 y equals negative 3x plus 2 equal y equals negative 3 times plus 2 equals y equals negative 3 plus 2. So answer is y equals negative 1. So y equals negative 3 x plus 2, y equals negative 3 times 2 plus 2, y equals negative 6 plus 2. The answer is y equals negative 4. So one more example. So, find the range value of the functions for the given domain. Y equals 5x, negative 7, negative 3, negative 2, 4. So y equals 5, negative negative 4, negative 7. So y equals negative y equals 5 times negative 3, negative 7. So y equals negative 15 because 5 5 times 3, 5 times negative 3 is equals negative 15. So the negative 7 is copyright. So y equals negative 15 minus 7 equals negative 22. So the answer is negative 22. So y equals 5x negative 7. So y equals 5 and negative 2 negative 7. So y equals negative 10, negative 7. So y equals negative 17. So y equals 5x negative 7. So y equals 5 times 4 negative 7. Y equals 20 negative 27. Y equals 17. So the range value for the given domain are negative 22, negative 17, and 13. So here are practice time. So find the range. Number one, find the range the value of the functions for the given domain. So y equals 3x plus 7, plus 1. That so here are steps. So sub its domain value in one at a time. So solve for y in it. So let's y value of the branch. So there here are some answers of number one. So number one, so y equals 3x plus 1, y equals 3 times 4 plus 1. So 3 times negative 4 equals negative 12. So plus 1, so equals negative 11. So y equals 3x plus 1. So y equals 3x times 0 plus 1. So y equals 3 times 0 is 0 plus 1 equals 1. So y equals 3x plus 1. Y equals 3 times 2 plus 1 2. 3 times 2 equals 6 plus 1. So 6 plus 1 equals 7. So the range, the value of the domain is 1 negative 11 1 7. So number 2, find the range value of the functions for the given domain. So y equals negative 2, negative 2x plus 3. So negative y equals negative 2 plus 3 equals negative 2 times negative 5 plus 3. So negative 2 times 5, so 10. So positive 10 to plus 3. So 13 plus 3 equals 13. So y equals negative 2 times plus negative 2 times plus 3 equals y equals negative 2 times 2 plus 3. So 2 times negative 2 times negative 2 equals 4. So 4 plus 3 equals 7. So answer is 7. So y equals negative 2x plus 3 equals negative 2 times 6 plus 3. So, negative 2 times 6, negative 2 times 6, so negative 12, so plus 3. So, the answer is y equals negative 12 because negative 12 plus 3 equals negative 9. So, the answer is 37, negative 9. So, that's all that is basic examples and definition of relation functions.